Oh, hi.
So far,
Yes, so far.
I think what do you people expect?
Because a lot of people who come, I don't know, they'll find me. So. Well, maybe not a lot, but a lot of the people who regularly show up, like. Some of them didn't need to show up. I appreciate them showing up though, and like, that obviously helped their understanding,
Right.
but
They were doing just fine.
yeah, they were doing just fine.
Oh, so you can see our grades and everything?
But I talked to people.
I'm at a 78 right now after she put on the points.
Yes, you can, if you get a better grade, it bumps.
Exactly, that's
So
why,
might as well, yeah.
that's exactly what I'm taking it.
A lot of people are, they don't even care if they'll up their grade as long as they're passing. That is what Mary said. Hello.
This is my last little jump that I can do.
Yes. 3% higher.
Literally.
You'll be good. And you'll be
Right.
good.
And Dr. Wilson's even put in everything yet. So we'll see.
Oh, okay. Yeah, that'll go up too.
Right.
Is he an easy grader?
Is he what?
Is he an easy grader?
Every once in a while for one of the questions.
Oh yeah, he'll help you.
Yeah,
I'll
but
help
then
you.
it's like, I don't know, I literally don't know how to do this. If you remember, we took for lab 5, what was lab 5?
On application?
Yeah, and it was like question 2, and you had to do all this
Yeah.
math.
Oh,
I told him, I was like, I
honestly.
literally,
Yeah, yep.
I don't know how to do this. He said,
Question-
okay.
Question 2 and 3 were flipped,
Ow.
so like, that's when he built my group.
Really?
Yeah, he said just do
Well,
that
not right.
first and then step 2.
Yeah, I didn't
So I did it for somebody.
Yeah,
In chronological order.
Yeah.
It sounded right.
he's an easy grader either way.
Mm-hmm.
Okay, good.
He's pretty chill.
Right, I don't stress that. This, we just, he even told me just don't worry about it.
Yeah.
You know, the excuse,
I just hate 6 in.
if you care to share, what do you want?
I don't know.
Yeah. I'm 78.
Okay.
The first, like, I kept forgetting we had quizzes, Marcus, and I at the beginning.
Such a young. It's
Oh, is it gonna get missed?
like totally. That one's bad.
Oh, yeah, if you do this lab, this exam, it's common, then it's really take you down, right?
Mine's easily.
Really don't. This is the same problem every time. I just don't. Use the board.
You need. I don't think it's either.
The next one. I have one that might.
You need extra marker, is that what it is?
Yeah, anything.
Try this one, I don't know if it works. May not be any good.
Hey, it made them. Sorry, that was my water level. Okay, yeah. I'm just gonna do like a bunch of naming and then a bunch of reactions, and then the rest of the stuff is kind of filler. So I feel like the naming and the reactions will be the bulk, and then you'll have a bunch of random information, but we'll go over this too.
No. Let's say. Oh my god, I'm really tweaking, I can't, I feel like
I just been looking at this like.
lost it again, you guys.
Yeah.
And I said to do the practice exam over again, and stuff like that, so it's like,
It looked really bad.
mess you up.
Yeah.
I also was seeing the class, but,
Yeah, I was.
I forgot the homework, homework that was due Friday.
I don't know.
I literally was, I think it was like 2 on Friday, I was like, oh yeah, I must be doing 11:59, no problem. I was sick, I was so sick, why did I say 11 AM? So, I was like, why is it no? I don't know why I thought he changed it to 11:59. He always did it once, I think, last semester.
Just use check.
I use check for every single one. Oh god, I bought it just for that class, I can't wait to stop the scratch
It's worth it.
100%. It's everything's there, you just have to do the math yourself.
You guys ready? Don't worry, there are other people watching and ask me to send them the link, so you guys aren't the only ones who are who are trying to be successful. Do not fret, but welcome. Small crowd. All right, so we're just gonna go through these. What's nice is that the naming all kind of combines on each other. So it's gonna be kind of similar to the last exam, because it'll go up to this, or it'll go up to the acids. So I did a bunch of different groups that we'll have to name just to show all the different combinations. Okay. So this right here is an ester. This has 1, 2, 3, 4 carbons. So that's going to be a butene OH with the EN. And then on this is an ethyl. So ethyl goes first. So we have ethyl. 3-hydroxy because the OH is a substituent. And then butan OH. So this cannot be cis or trans. If it was cis or trans, the cis and trans would be after. And then we'll talk about it, what it is with the nitrogen, which is, but it's not cis or trans. Because if I were to split this down the middle, you can't have something different if there's 2 H's. So if it's on the end, it's not gonna be cis or trans. Any questions about that one? So this one, I did this one intentionally because we just learned about amines, but they are a lower priority than ketones. So that's just to help reinforce, usually anything with nitrogen is gonna be after anything with oxygen. So 1, 2, 3, 4, 5, 6. And we have, this is an amino group. Right, when it's just its own thing. And then this is a ketone. So what we put first is what's on the nitrogens. This would be N-ethyl. Five amino. X and 2 or 2 hexanone. Whichever one you prefer. Any questions about this? Even though I don't have an example up here of an alcohol that's just named like after an alcohol. Just a reminder, if you were to name an alcohol, the ending would be OL. So sorry for kind of have it, but I just. So if we were to look at this one, she'll probably tell you if she really wants you to use orthometa. She will tell you if you put numbers. I don't think she'll mark it wrong if she doesn't specify. So you can do it both ways, but this group right here, no. If your marker dies, would you be upsetting?
You have to specify that the apple is on the net
Yes.
for B. Okay, wait, I was looking up top or one.
Oh, no, you're fine.
Sorry.
So you're good. Yeah, I poorly said there was an ethyl twice, so I could have done something different.
Yeah.
But in both of these cases, this one you don't have to specify. If on a nitrogen, it's lower priority, you do. So you don't have to write like O ethyl. Just write N. Any other questions about that? This is a phenol, however you pronounce it. And then ortho, meta, para, it's meta away. So this would be meta isopropyl phenol. Or if you wanted to, this would be 1 and this would be 3. It would be 3 isopropyl phenol, if you want to do it that way. You don't need to indicate what's on 1 because it's insinuated that this is 1 because of the name. So any questions about this? And I don't think she'll be picky. If she is, I'm really sorry, but she usually does specify if she wants you to use it or not. We have this one right here. You have a triple bond on this end, and we have an amine on this end. So we're gonna start down here. That's a higher priority. 5, 6, I. So we have, this is no longer an amino group. The end is gonna be an amine. So I'll just start at the end for this one. It's gonna be a hex. 4, 9. 2 amine. So we have triple bond. 2, and yes, you do have to label where it is, because this can be anywhere on the molecule, right? The amine could be here, it could be here, so you do have to label it. And then the only thing left is 3 chlorine.
It's okay, that's document.
Well, no, this is yours. I'm trying to preserve it. I feel so bad.
No,
I'm gonna kill these first. I just pressed really hard, maybe that'll do it. Any questions about this one? And there's nothing attached to the end, so you don't need anything in front.
Can you also write it as 4-hexene to amine, right?
Hex sign. 2 amine. Right. This one, you started the double bond, and remember, you always have to number through the double bond. So this one is nice and challenging. Because technically, if you were to number either way, right, everything would have the same number. If I were to start here, the bromine and the isopropyl would have different numbers. But the reason why I went this way is because the bromine and the isopropyl are the same priority. And so I go with which one is alphabetically first. So if you have more than 3 substituents on a ring, right, where you have to choose which way to go, you go with the way that's alphabetical. So we do for, oh my gosh. I click it. I made it worse.
It's a thing where you like swing it around like.
So if you swing it,
Yeah.
3 bromo, 5 isopropyl. Propyl. It's getting less and less. Cyclopentene. You don't have to label where the double bond is, because it's assumed that's where you start, so you don't need to do cyclo 1-pentene or pentene. But then you have cis or trans. And this is any questions about naming? This pretty much covers a lot of it. I didn't do amides, but the only thing that they're different from esters is that instead of it, the ethyl being in front, let's just throw in cis here. Cis. So let's just hypothetically, it's cis, ethyl goes before cis. If this is a nitrogen, cis would go before the NF. So they're named very similarly, except with an oxygen, you don't have to put the O. And if it was cis or trans, the cis would come after. It's another group. There's not, I don't really, aldehydes end in al, and they're always number 1. But other than that, I'm not sure there's any other groups. So any questions about these? This is where I crack into the notes, because she put up there's so many reactions that we did.
Yeah. It's like, seven.
Yes. That's it. You're doing more than. You a junior? I say all three now then.
That's like, do nothing legendary. I also want to take. Easy change. That was.
I switched to the chalkboard halfway through the alphabet. I'm I try every time. I have faith. But I always have too much faith. Now we should.
Let's do it anatomy one.
Thursday.
Monday. You see it Tuesday the first.
Yeah.
Is
Is
it related or just?
No. 6 inches.
Change. That's
Like,
right.
hit bullet points, yeah.
That is fun, but testing is not, is it?
I don't think those are like. It's like a big like chemistry.
I don't think so, yes.
It's like the hardest exams I've taken here.
What do you have?
My trial. She could use it.
Mhm.
She didn't watch it.
I took it last year. I had, Dr. Ford for lab. First semester, second semester, I had what's it called? Dr. Ford.
I heard she's tough.
Her tests are tough because you can only go through one time. Like, you know, per practicals.
Yeah.
Yeah, you can't like send, or you can repeat. Of what you finish, you can go back and go the many times. Before. So, where she lives, she's like one time and you're done.
Yeah.
That's it. I was like, that's was so hard.
It's like that's.
Not at all. Nothing, you can't live without skill. All these things where it's like you put something. It's better to put something than nothing.
Let's see how many reactions I can.
Oh, but that was, I bet, I should say like hard. So I'd rather not her do response. Cause I can get partial.
Without, since they don't,
Yeah.
nothing. I think for, I don't know about her test, for Ward's test, she did multiple choice and then free response. Multiple choice was not bad.
But she doesn't teach.
She only teaches cancer out.
Yeah.
Funny enough, she actually prefers teaching than she does being, what was she, department chair?
I think so. Yeah.
She was like, remember when we were, she was like transitioning, she said, I have to become it under medicine seniority, so I have no choice, I really don't want to, but no one else wants to.
We're gonna do these, and then we have oxidation and reduction. Next, so we'll start with these ones. These were from the first exam.
Oh, so these are the, what's it called, did we do hydrogenation?
Yeah, so we're gonna get to that. This is halogenation. Yes. So we'll get to hydrogenation.
That's what we just did there.
That may have been not this one, but the past one. I skip over it?
Actually.
I think I may have accident. Here is hydrogen. Oh. I think that was still a first test. But there it is, so we'll do it. Get rid of them. I don't think that's drawn correctly, like orientation wise, but it's okay. Alright. So if this is bromine or if this is chlorine, it doesn't matter which one, they act very similarly. If you're just blasting this with bromine gas or chlorine gas, the double bonds are gonna break. And in each place, right, these are just, if you were to erase this, there'd be a spot here and a spot here for them to bond. So you're basically, all you're doing is you're just erasing the double bond and then putting bromines at the edge of each double bond. Kind of similar to this one, right? If you're just blasting this with a bunch of hydrogens. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Same concept, it's just gonna replace all of these with hydrogens. You don't have to draw them all in. But you can if you want, right? I'm only gonna do a little bit. But down here to adding, up here to add. This one's probably the easiest one. If you see this, you just draw it without any double bonds or triple bonds.
Wait, why they're double bond? Wait, I'm confused on what's more interested at the bottom. There's a double bond on the far right.
This is a double bond.
Yeah,
Mhm.
oh, it just gets rid of the double.
Yep, that's all it does.
Okay, yeah,
And the triple. And so it's just like this one, except instead of bromines, it's hydrogens.
right.
So they're very similar.
And you said we don't have to draw the hydrogens in.
You can just draw this. That's all she wants. That's why it's the easiest reaction you can get. Just draw the backbone. Any questions about that? This one again is pretty obscure. Let me double check. It's. And I flipped all the way back.
Do you know if the final is where we have black? Or like where we have our,
Oh, where we do it?
yeah,
Oh, I think it's in here.
it's in here.
Yeah. So this one, you're starting very similarly, you're just adding the gas, and then you're adding iron. And then Cl3. If this were a bromine, it would be the same exact thing except with bromine. So the only thing you really have to remember is this, like Fe, Br3, Cl3, whatever you want to call it. But this is if you have a benzene. Any questions about that?
Oh, it just added it.
Yep, that's all. It just adds once.
Does it matter where?
No. If you ever want to take more organic chemistry, it will eventually matter where. If you were to add something else on, it matters, but it doesn't matter right now. Any other questions? We're good. Okay. This one here, this is adding. These do act differently, which is why I do them differently. This one is gonna add to the highest substituted carbon. And then this one is gonna add anywhere. So what that means is that the carbon that's the highest substitution, which I already pointed out, we can go through and do it, for the highest classification. We also write classification. That's where it adds. So what kind of carbon is this? What classification?
Primary.
Primary, secondary, tertiary, primary. So it's going to add where it's the highest and replace that hydrogen. So the hydrogen is going to leave, bromine's going to go in. The bromine, if she were to ask you, this would have only one response. This methyl wasn't here. There's technically 2 carbons where it could attack. So that's just a side note. If it's like a symmetrical molecule, there may be more than one bromine answer. But if there's only one of the highest classified, then there's only one answer.
So for that, would we put a bromine where both could go, or would we draw two separate backbones?
two separate backbones. And that will be shown, we're gonna do the chlorine ones in a second, and that'll be pretty clear how to do that. So for chlorine, this can go anywhere, so she's gonna want probably most of the options. There's a chlorine here. There's a chlorine here. There's a chlorine here.
Oh, so 3.8 is goes in each and every single.
Yep. And you just draw 5 separate. The reason why there's 6 carbons, there's not 6 over here, is that these 2 are symmetrical. So if I were to put a carbon here, or a chlorine here, or here, that would both be on number 1. So since they would both be on number 1, you only write it once. Any questions about that? So the difference between this and this is that this is single bonds. And if she asks you what this is the symbol for light. So for halogenation, with light conditions, it will substitute a hydrogen. Any questions? So we're gonna go back to talking about substitution, which is why I intentionally drew the same molecule. It's pretty easy. But these are not hydrogenation or halogenations. These are typically, pretty sure, acid. So when you expose a double bond to any of these things, and I drew them all the same way, but she may write these differently. So if it was H2O, if it was HOME, if it was hydrochloric acid, so methanol, hydrochloric acid, they're all going to do the same exact thing, which is get rid of this double bond. So that's why I drew the backbone. That's all the same. And the hydrogens are also going to attach in the same place on each of them. So the hydrogens are going to attach here. And then your bigger molecule, that's going to attach to the highest number classification of a carbon. So if you see a double bond, and then you see anything with this H and then something else, the double bond is going to be replaced with the H and whatever's attached to it. Yeah.
Right, so, sorry, do we need to put the H on the back?
If I ever draw the H in, I mean, do you see them drawn normally? No. So they don't matter. Only thing that matters is this. This just helps visualize it. Any other questions? Now, very similarly, we can go in reverse. So this one, we're going to do highest substitution. So if you have water or the OH or an OMe or an HCO, you can actually remove it and make a double bond where it once was. Now, what I mean by highest substituted is because if I were to erase this, if I were to get rid of this, and we have this blank here, a double bond can form either here, or it can also form on the other side. However, similarly to these, you're looking at which carbons have the highest classifications, and you want to include those. So here, I can just draw both. If I were to draw both, we look at this double bond and we see how many carbons are attached to it. Or how many carbons are attached to the carbons in it. So we're going to start here. We have 1, 2, and 3 carbons attached. So that's tri-substituted. We look here. There's only 1, 2. And so that's dye substituted. So you're looking at what's directly attached. There's a hydrogen there. And here, there's also the 2 hydrogens. So you can either look at it from a substitution standpoint, like try and dye substituted, or you can look for the highest classified carbon. So either of those ways works. Any question about this one? So if she were to ask you to draw the product really quickly, you would not have to draw this one. You could, but if you were to draw that, you would want to indicate that it's the major product. You wouldn't want to like circle it or something. Because if you just put both on there, she's gonna think you got the question wrong. If there's one clear answer. Okay. Any questions about these?
Is it what they're called acid reactions? Or
these ones aren't acid, they're like hydration reactions. This is a dehydration. This is like you're hydrating it. Right, you're adding water, you're adding something. This, you're taking away the water. Because there was an OH here, you're taking away an OH and an H. This is hydrogenation, halogenation. I feel like you guys know what polarity is. Solubility, hopefully.
Dipole.
Yeah, polarity is just the presence of, or polarity allows dipole to happen. Trying to get to more of the reactions, really,
She gonna ask us for anything else other than reactions and data.
Yeah, so like she may put like a sugar on there, or she may ask you, she'll ask you to do DNA that you had to do on the quiz. That was what we just did in class, like the deoxyribose, it wasn't a reaction. I'm telling you other subjects on it. Let me quickly. We'll go over oxidation and reduction. So what I'm probably not gonna go over today, just for like time's sake, is there's like a few little asides that she would talk about, like polymers, like the billiard balls and Goodyear tire, stuff like that. The difference between cellulose and glycogen, that type of thing. Because she like would go on a little rant and just give like a bunch of facts. I probably won't go over that stuff. She will probably pick one of those things to put on the exam to have you explain.
So what was the first one, Goodyear versus?
There's Goodyear, which was the tire one, and that was vulcanization. Then we have the billiard balls, which is backlight, and that's just like a complex polymer. That's basically just knowing about it. I think.
how to clean
Rubber.
like that one, how to soap clean.
Oh yeah, how to soap clean, that's another one that you could do,
Yeah.
right? There was another one. Just on the tip.
Oh, perming.
Perming is a good one, yes. Geez, you're on the ball. She tells these literally every semester.
Perming's the one with the sulfide bonds, with the.
It's oxidation reduction. We'll do
Yeah.
that, yeah.
It's like, I think it has like, it starts with SH and then it breaks, and then it makes the hair like.
How about that?
Yeah. I think we're missing one. I think there's. Maybe that was it.
Practice.
Just a practice exam for this?
Not for the final.
Oh, okay, I didn't know, I didn't check yet.
I would say probably not. I haven't checked either.
Yeah, I think I looked, it was not there, but I think it's like on every, each test, practice there is, she has one little fun fact, little biggies on it. But
Yeah.
The last one was so, and how it cleans.
Again, she's not gonna ask you a lot of those obscure questions, but she's gonna ask you one or two. Because those are like questions that aren't necessarily hard, they're more recall, and so you're more likely to get them right. It's not like you're doing a reaction.
Yeah.
Mhm. Got it. CR207. A2, what I actually say, okay? So what we're gonna go over, this is oxidation first. So we're gonna go over a strong oxidizer and a weak oxidizer. And so I don't think, did she make you memorize what they were? Yeah, or did she just say strong and weak?
I know the PCC is weak.
Okay, then you probably may have to memorize it if you,
Handout.
yeah, on the handout, it's on there. I just didn't know, because sometimes she'll be like, oh, I just gave you extra information, but anyways, PCC is weak, so you're right. It's weak. And then this is the symbol for oxidation. And then this would be strong. So really quickly, just general, what she'll do is give you a bigger molecule. I'm just breaking down each of the individual components. So if it's a strong oxidizer, an aldehyde is gonna go to a carboxylic acid. If it's a strong oxidizer, a primary alcohol is also going to be a carboxylic acid. And then with a strong oxidizer, secondary alcohol is going to become a ketone. Now, if it's a tertiary alcohol, this O can't make a double bond. So this is going to be no reaction. Any questions about these? These are pretty much memorization. There's like kind of a pattern. If you remember one of them, it's kind of easy. And if you got this way, then you can go the other way too, with reduction. Any questions?
PCC also weak, I think that was on the last, this was something.
Oh, PCC, yeah, so this is weak. This is strong.
Sorry, PCC.
It was like something on the last.
Ooh, though, I know what you mean. So that's the last practice exam.
Yeah.
And that was for a forming and a mid question. You
Uh,
don't need to know about that, yeah. We know about it as heat.
Okay.
So if you take an acid and an amine, that heat makes it mid. ECC, just another way to do that. This is PCC, so sounds similar. Maybe that's why she didn't include DCC.
Mm.
Oh. But you did last year.
Last year.
Thank you. Any questions about this one? So if it's weak, aldehyde cannot go any further, there's no reaction. A primary alcohol, again, it cannot. It can't go all the way to the carboxylic acid, and so it stops at the aldehyde. And then a secondary is easy, it always becomes a ketone, whether it's strong or weak. And once again, a tertiary alcohol would not react.
Wait, why doesn't the last one have hydrogen attachment?
Oh, because this is a secondary alcohol, right? So this is a carbon over here, 3 hydrogens. This, since it's on the end, this is the carbon. It's on the end, and so it becomes an aldehyde, and you can't keep going if there's not another
Okay.
carbon attached.
Yeah, I see.
It'd be like that height, maybe?
Yeah.
erasing it like that. Any other questions about this? Because then we can go in the opposite direction. With a reducing agent. So we have these. So if you were to reduce, if you have all of these rules here, it's kind of easy, you can just reverse it. So if we're starting with a ketone, we have a ketone over here. We know that it's going to be secondary alkali. Oh, wrong spot. Same with this one, right? We have the reverse up here. An aldehyde is just going to go back to primary alcohol. And then same with a carboxylic acid. It's going to reduce first the aldehyde, right? And then it's going to reduce again to the primary alcohol. So that's the same going the other way, right? If you have a strong oxidizer with a primary alcohol, it'll go aldehyde first and then all the way over to the carboxylic acid. Which is why it stops here with a weak one. Any questions about that? We're gonna quickly do sugars. This is a review. I know you just had a big sugar question on your last exam. So I'll doubt she'll give you a big one, but she may have you draw one and it's Haworth projection. So that's what I'll be going over. Especially since starting with the building blocks, you can answer the double one pretty easy too. So
We should probably re-memorize. The draws.
yeah, that's what I'm saying. I'm gonna do one. Or we'll go over the name really quick. So we were to look at this. Ketose. And then it's going to be a 6-membered ring, making it a hexose. So this is a keto hexose. Start 6. Or I'm gonna count in the opposite direction. Just so the anomeric is number 1. So a good rule of thumb is that if there's 3 crosses, if there's 3, that equals a cyclopentose. If there's 4, I guess I wrote it wrong. So that's just the general key. So seeing that, right, I'm gonna start with my 6. I'm gonna number 1, 2. So I actually did label it I said I was gonna make the anomeric carbon on number 1, and then I lied. So, sorry. Regardless. This O is number 1, that's the one up in the corner. And then in order to have a D sugar, she may ask you what makes something a D sugar. The OH is on the right side. So that also means that it's facing up. So from there, we look at these, right? The ones on 3, 4, and 5. If it's on the right side, it's down. If it's on the left side, it's up. So number 3 is on the left, which means it's up. Number 4 is on the right, and so is number 5. Now we have our anomeric carbon. This is what's going to determine whether it's alpha or beta. So what do you guys want to draw, alpha or beta? I have no preference.
Oh,
Alpha. So if you're doing alpha, it's going to be trans to the CH2OH. So you're going to draw your OH in, and it's going to be trans. Now, I didn't make this one an aldehyde, so if this was an aldehyde, it would normally have an H. But I actually made it a ketone, right, because it's a ketose. So ketone, it's just a CH3 on the other end. That's all I did there. I don't even have to really do that, because this is a methyl itself. But I like to draw it. So any questions about this one? You want to do another? Are you guys good? Good. And these aren't too bad, but it's just remembering all the rules from the last time, so. Ooh, really quickly, is this a reducing sugar? I know.
I don't think it's a hemiacetal.
So,
Actually, sorry, it is a hemiacetal. It is a reducing sugar.
yeah, because if this is here, right? If a OH on the anomeric, that equals it's reducing. So that can still be oxidized by something. If it was an aldehyde, it could be reduced by an aldehyde specific.
So it just had an H.
Yeah, if it just was an H here, this can be reduced by anything. But most importantly. Aldehyde specific. So that would be like Benedict solution. And then Tollens. And so if she were to write on the test, what could I reduce this with? I don't know, or like name an aldehyde specific, I don't know how she would frame it. She actually may put it in like a reduction question, so she may give you this. And tell you to use it for both. And if you were to use Benedict's, which is Comparty. This one would react. So most importantly to remember here, when we're looking at these, especially if they're aldehydes, they're at risk for aldehyde specific oxidizing. Any questions about this? Again, if you were to look at a disaccharide, which I doubt she will have you do because you just did it, you're looking for alpha or sorry, that's actually second. First is anomeric carbons, alpha beta, the glycoside bond. And then is it a reducing sugar? So again, doubt she will give that to you. That would be kind of foul to have it across. That would be like 3 tests technically, because you learned it before. So I doubt she will do that, but if she does, I'm sorry.
Or if it, for the disulfide, if there is you can just, if there's one times acetal, the whole thing is reducing sugar.
Yeah. It's if it's an acetal, it's a reducing sugar. Oh, and I realized that I forgot to go over oxidation of sulfur. So let me do that really quick. So, like she was saying, with the perms and everything, your hair naturally has disulfide bonds. The more disulfide bonds your hair has, the curlier it gets. And so when people are getting perms, they are purposely oxidizing these bonds and making them form so their hair gets curlier. So if you were to do this and oxidize it, you make a disulfide bridge. And notice the 2 sides aren't even. They don't have to be even. It could be 2 different things. Just make sure the chains are correct on the other side. That's just another reaction I forgot. Any other questions about sugars? Okay. So really quickly, she may want you to have to draw this. So I'm gonna draw. Okay. Okay. So this is weird looking. But whenever you have, remember carboxylic acids look like this. So it's actin. Whenever you put them in water or just put them near each other, really, they form this dimer, which is similar to like a polymer. You think of a polymer having multiple units, a dimer has only 2. And so it's held together by hydrogen bonding. I could see her possibly asking a question like, how do 2 carboxylic acids form a dimer? Draw it. Or something like
So
that.
she would just want us to draw a dimer.
Yeah.
The,
I can see her asking a question about it, yeah. So these aren't real bonds, right? You do a little squiggle to show that they're intermolecular forces, but it's forming that hypothetical dimer. And so with that, I'm really gonna try and fit all these on here. I think I am. And the reason why I draw them all next to each other is so you guys can like see the patterns and how it progresses as well. You're basically doing the same thing, just slightly differently. So none of these right here are the two-step problems. The two-step problems are when you start with something that's not a carboxylic acid. So we'll do that second. So all of these are one step. All right. This is the carboxylic acid, which is obviously an acid. Let me actually not write, because that looks like conjugate acid and conjugate base, so I'll see that here. This is an acid. All of these right here are bases. Except for this one. This one needs a push. So this one is technically, you're throwing it in acidic solution, but that's because it needs a catalyst. But regardless, each of these things, right, so minus the heat and minus this little acid symbol, all of these are reacting as that base. So here, you even draw them like this if this helps. With an acid and base reaction, it's gonna take that, leaving it negative, and then you have your base gaining a positive. Actually, I'm a liar, these two are acid and base. Any questions about this one? So if you follow the same steps, right, you're starting with an acid, you have your base, this OH. It's gonna grab that hydrogen because it wants to make water. So instead of H3O, it's just H2O. And then since you have your nitrogen here, what she's gonna want you to do is draw that. Just attach it there. And then something crazy she may do is say name this. So if we were to name this, I'm throwing in different skill. You start with the acid. That's sodium. And this is 1, 2, 3, 4. Sodium. No, wait. Since we didn't get to name a salt earlier. Any questions about that? So these next two, when you see a catalyst, that means that it's actually not an acid-base reaction, but it's gonna be a synthesis reaction. So, all right, catalyst equals synthesis, or if it helps, substitution. So what I mean by synthesis is you're basically adding this to your base compound. Adding this to your base compound. So if you see an alcohol and acid being added to a carboxylic acid, basically the OH and the OET are going to do a switcheroo or a substitution. So when you see something with a catalyst, you're not taking away this hydrogen, you're actually just swapping these two things. Any questions about this one? So very similarly, this next one right here, we're going to be substituting this OH with the N. And then you're gonna have water as your result. So this is when you're making an ester. And this is you making an ester. Her mate's dog is over. He's 10 years old and he's a Yorkie and they shaved him like Karen, like a Karen. He's bald and then has a blonde bob.
Oh,
He's actually atrocious. Like he's cute. He's like, yeah, he's sitting there and watching TV. I'm like, okay, thank you. Anyways. We're not harboring a teacher there. But any questions about these? This one is an acid-base reaction, so you don't see a catalyst. So this nitrogen, I'm gonna draw the arrow all the way up here. This nitrogen is gonna come and steal that hydrogen. So you end up having, once again, that O minus. And then, sorry, I got a little ambitious with the bottom. So if you see it with heat, you're making it a mid. If it's no heat, then it's an acid-base reaction. Any questions about these? Now we'll do some two-step ones. We'll do an acid and a base one. So we're going to do a basic and an acidic one. I chose different things to put on it, but the rules apply for both. So even if you were to switch these, you would follow the same rules. So if you remember, we needed a catalyst in order to do this. It's gonna do H and then whatever. Again. Right? You typically needed a catalyst, whether that be acid or heat. And so we need a catalyst with this too. So it's always gonna be water, and then it's gonna be the hydronium ion or the acid ion. So if we are breaking these apart, we're basically swapping this for this. If it's in a basic solution, right, the acid is gonna keep reacting. So if the acid keeps reacting, it's also going to have a negative charge. So this would be an example of a two-step. If this were a nitrogen base here, right, if it was, just say it was this, you would end up having your acid. So the only real difference is that when it reacts with a nitrogen as a base, it doesn't pick up a charge. It just becomes base. Because nitrogen itself is a strong enough base that it doesn't need to have a charge. H2O and its conjugate, right? This is not a very strong base. It has to be stronger and take that negative. This is strong enough. I don't know if that helped. Maybe I'm just floundering. Any questions about that? So for this one, again, very similar. Except this time, we're in an acidic solution, so it's not going to react with the acid, going to react with the base. So we're gonna have H3 plus and plus. Any questions about the two steps?
So when you're reacting for the second part, you just react to what's the catalyst is?
So like it's whatever the opposite of the catalyst is pretty much. So like this is your base or this is your acid. And then if you're in a basic solution, that acid's just gonna react again. Your base isn't gonna react again. Same with here, right? If this was in a basic solution, this would not react, it would be the acid. So since it's an acidic, this is the conjugate acid and this is the conjugate base. You don't have to know that it's that, but if it helps you, it helps a little bit. Any other questions about these? Yeah, because a lot of like your first test, like whenever I go over like the big reviews, I'm like, maybe there wasn't as much as I was thinking. Because your first test is literally all naming and like basics. So it gets harder with the other ones, much harder. But it builds up upon itself a lot. Okay. So I'm gonna move on to lipids. I will expect her to have you draw you lipids. And so we will go through the list. We have fatty acids. They have a long tail with a carboxylic acid on the end. We also have waxes, which are fatty esters. Yes. And they look like this. Any questions about those two? Those are probably the easiest to remember. Then we have triacylglycerides, which are a little bit bigger. But if it helps, right, you can start with the glycerol backbone. And then the triacylglyceride. Is just this backbone with 3 fatty acid tails. Now, something that she may have you describe. Again, she could ask you the difference between cis and trans triacylglycerides. So cis triacylglycerides are solids because there's more dispersion forces. So cis equals higher dispersion, which means higher boiling point, melting point, or, oh my gosh. What am I saying? I meant saturated and unsaturated. Saturated, okay, let me just start from scratch for this. Saturated triacylglycerides do not have any double bonds or triple bonds in the tails. And so they're going to be compacted very tightly together because there's going to be no kinks in the chain. And so examples of saturated triacylglycerides would be like butter, animal fat, other things like that. That's what you used in your soap lab. You probably used lard or oil or something in order to make the soap. That would be this. Now, if it was unsaturated, that means it can either have cis or trans bonds. And so cis is what's natural, right? And that equals lower dispersion forces because they end up looking like this and pointing every direction, right? The tails. And so they're gonna have lower dispersion forces and then lower boiling point and melting point. Another question she may ask you is why are trans fats bad? And so cis fats occur naturally within our body. And again, there's stuff like olive oil. Every time I try and list, I really can't list lipids. So I'm gonna stop there, but think of oils, stuff that's not solid. That's usually unsaturated. But then when they were shipping it across the ocean, they were able to blast it, break all the double bonds. And so blast it with H2PT. They all become single bonds, and then over time, they naturally revert back. So some were still cis, some were left single, and some were left trans. And so trans fats are bad because our body doesn't know how to process them, and since they look like saturated fats, that's why our body doesn't know how to process them, and then they end up clogging our arteries. So that's why we don't use margarine anymore. That's why they tell you to avoid trans fats, because increased consumption of that over time builds that. So any questions about that? Going to erase this little part. And I'll go over the mechanism for soap, but I won't go over everything. So if she were to ask you to show the process of saponification, it's basically you making soap. So you have your fat, and then you add a strong base, and then you end up having your little tails that are called surfactants. And then from there, it can look like this, and then they create micelles. Micelles in water, the non-polar tails are in, the polar heads are out, and they pick up the dirt off your clothes, and that's why soap works. So this is how soap is made. This non-polar portion allows for dirt to exit your clothing, allowing your clothes to be.
Can you say that last one?
I can draw them myself.
Or what was the process again? Like the soap goes in through how does it?
Oh, okay, so you have the fat base, this is soap.
Yeah.
Then, like, you have your shirt. You have your shirt. And any of the dirt that's non-polar can actually be carried off by the tails. So in solution, these form micelles that look like the ball. Their dirt is inside of them, and then the water is able to wash them away because their outside is polar. So,
Backbone for the, like after it's mixed with the base.
you technically get glycerol, but you don't have to write that. What she's mainly looking for is this. She's looking for saponification. Any questions about that? You want me to pull up a terpene? Josh, did she make you do one on the exam?
Yeah,
Who?
there was two of them, but you chose one.
Oh, okay.
Or it was the same one.
Oh, yeah, sorry, yeah, so same
You
one.
just like chose what they were in.
Yeah, when I did it,
I think it was a try.
I can't remember. But I, when I got only one part wrong, I thought it was just like any five. And like, I didn't know how to actually draw a thing.
Yeah, the ones that are like cyclopentanes throw me off.
Oh,
She had it like,
It was like two
there were
different.
two hexanes connected and there was an isopropyl, which, you know.
Oh, okay, here, we can do it like that. I was.
Maybe. It looked like this. Yeah, I didn't.
Oh, so look at the one I drew up there, it's pretty similar. Pretty similar. So my hint to you, and what we'll do for this one is, did you not, you did start out on the outside? Yeah,
Do this.
what I would do is just start one and then go in, and it's like your mission to number all of them on side, inside the ring.
Got it. I honestly did it backwards. Because the 5 is usually the ones.
It doesn't matter, but it could be, yeah. I number them every which way when I'm doing it.
Are we gonna have to do steroids for this exam?
But yeah, but it shouldn't be too crazy,
Yeah.
like, she'll give you what is on it, you just have to know. But I'll go back. Okay. Centerpine, yay, it should be a diterpene. So it should have 20. But if I were to start numbering, I always start numbering, or like, it sticks the far most out, so I'm gonna go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
Thank you.
Mhm.
That was on screen.
Yeah,
I can actually, can we just draw that one? Yeah.
I really just thought it was just, as you said, 1, 2, 3, if you can get a 5-part, like that counts as one isoprene, whatever, but that's what I did, and she said it's like one of them.
You had a different one, but they all look kind of similar.
Oh, yeah, one person.
3,
Huh?
Just like,
just this.
I was. Honestly, I don't think I saw it.
5,
I was like,
I think she just wrote that.
yeah.
2, 3. 1, 2, 3, 4. So I would ignore it. How did you number it?
That's the name I got right,
2, 3, 4, 5. I think she really wants that like 1, 2, 3.
and
I
then.
think she really wants that. I don't, they're groups of 5.
Right.
That's all I have to say. I don't know if whatever. So I would just go through and make sure, because I tend to draw them naturally that way anyways. Like, look at this one here, like there's natural branches. And so what I do is I just make sure I do 4 in a row and then try and grab one of these as the off one. I can try and redo this bottom, because I think the only one that doesn't have a branch is this one. So she would maybe mark me wrong. But at least with this one, you would have gotten like 3 out of the 4 right, I guess. I could try, I really. I like the way I have this. Um. Usually bridges will make themselves known. But a good way to practice is there's like a billion terpenes that exist. And so that was a diterpene, so she's probably gonna give you a diterpene, because I'm trying to be excessive. So you can literally look up examples of diterpenes. I can do the. try this one. Wanna do another one?
Yeah.
This one. Let's start very clearly. Yeah, I wanna start down here. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that one actually does have all branching. I think the key with these is just being confident, because I know if I do this straight away, I don't know if I'm doing it right the first time. And most of the time I just try it, it's right. So just kind of gun the numbering, don't be scared, and you'll probably get it at least close to right. Because when you start overthinking about the numbers, that's when like you lose the problem, and it's like, okay, I'm thinking too much, because there's 20 carbons I have to count. So. Any other questions about terpenes? I would recommend looking up examples and just drawing them down and then numbering them. But I doubt she will give you, again, I don't know how much will be from last exam. So,
Especially when I focus on the new stuff, so.
yeah, that's what I'm saying. I'm like, it shouldn't be too crazy.
You go over at some point, like the sugars you most recently went over.
Oh, the double?
What's the stuff we were doing on Friday?
Oh, yeah,
The Friday before, because I missed that class.
DNA.
I think so.
Yeah, no, I'll go over that in a second. We still have, oh my gosh, 10 minutes? Jesus, I'm so sorry. I thought we had time. No. Okay. So that's on me, damn. Okay, so. Does anybody have their like nucleic acids out?
Yeah.
Cause I can draw the base first, so.
It's nuts.
Yeah, perfect. Just so I can see them, and so if I write them up, you guys can also. So,
Oh, also, what I meant, sorry, was the it's like the 9-month stuff
oh, yeah,
and
the protein,
yeah,
yeah, okay. Do you have that sheet, right?
yes. It has the basic.
Mhm.
Or have this.
I know, if you wanna do the proteins, I'll need that.
Okay.
But, okay. Really quickly, because I am an idiot, this is deoxyribose. And then this is ribose, so, she may ask you to draw a ribo. Oh my gosh, RNA or DNA. So. If we're looking at this. So if it's a nucleoside. She'll name it, basically like it could be, I guess. Uracil is a bad example. I don't know what thymine would be. What would thymine be? Thymine? I don't know. But we can just do this. Oxy. So deoxyuracil is gonna have the deoxyribose, and then it's gonna have whatever this nucleic acid base is, and then you're gonna attach it where the H is at the bottom. So all of them have a pretty clear spot of attachment. If we look at the paper, they all have an H down at the bottom, that'll be very clear, and it attaches there. And so she'll tell you whether it's a deoxy or not, and then she'll tell you what base it is, so that's the two part. If it's not deoxy, then she won't put deoxy. She'll put deoxy if it's not.
How do we know if there's a phosphate group attached again?
Yeah, so that'll be if it's tied, so that's a nucleotide, and I'm pretty sure the naming was, yeah. You can do, let's just do uracil. Five phosphate. So I'm gonna redraw it. H, and then on this CH2, the O becomes a part of this phosphorus group. So if she wants you to draw a phosphate group, she's gonna indicate 5-phosphate. Just because of how naming works, I don't think she'll make you go the other way. I think she'll give you this and then tell you to draw it, which is nice because everything other than the ribose and deoxyribose should be either in the name like the phosphate or on the paper. So these shouldn't be too bad.
You can learn how to do backwards.
Probably not, no. That's what, she's probably just gonna give you the name and then ask you to draw it. But I don't know. Time
Take
for,
it if you want. Just for the right hand.
you want me to do the question?
Or something like it.
Yeah.
The nylon and the protein.
Yeah. We'll do nylon 52. All right. So I don't know if I will have time to do the protein, so which one would you like me to prioritize?
This will be yours.
Oh, first.
You're good,
Sorry.
you're good, no problem.
I only have time to do one, so which one would you like me to prioritize?
Which one do you think she's gonna do both?
Yes, I would say the one that's harder is nylon 52.
Okay.
She puts it together.
yeah.
Letters.
Like, I don't understand, like, when I saw it the first time, I did not understand it, so, I feel like that one's harder just because you have all the bases there.
Yeah.
If
Okay.
if you're making it, right, you basically have all of them here. All you're doing is taking alanine, and instead of this being an acid, it becomes an amide. And it attaches to the next one where its amine is. So you have all of them here. You just take out basically water.
Okay.
That's all you do.
Okay.
So, you don't have to memorize any of them or anything.
Got it.
But nylon, we'll do nylon 52. The nylon 52. And this is the number of carbons. And then this is the number of carbons in the diacid. And this is number of carbons in the di. So basically what we're making here is we're making a bunch of peptide bonds. And so 5
What does it say next to the carbon, number of carbons?
diacid and then diamine. So this one's for the diacid, this one's for the diamine. So basically what you're doing is you're taking that many carbons and you're writing it down, and then you're adding acids on the ends. So it has 5 carbons, 1, 2, 3, 4, 5. If you wanted to shorten it, right, you could put CH2 3 in the middle. But that's where sometimes people get confused. So I always like to draw it out first and then condense it, so I know I have it right. So if you count, there should be 5 carbons total.
Is it 5 carbons including the 2 things at the end?
Yeah,
So Why is it CH2 3?
Because in this middle, there's 3 Cs and they each have H2s on them. Yeah, so that's the way to shorten it, when you actually go to write out the whole thing. But I recommend drawing it first and then doing this.
So if we just repeat what you got there? For however many repeats you want?
No, there's a diamine, there's another part to this, I know this was only
Yeah.
unfortunately. But then you have a diamine, I'm actually gonna do nylon 54, just to make it fun. One, two, three, four. Okay. Now in this one, in the diamine, right, you don't count the ends. So in this one, since it has carbons, you count it. This one, you end up having that. So if I were to shorten it, it would be NH2, there's a C here. They're all gonna be CH2s. CH2, 4, NH2. So now what we're gonna do is combine them together by taking out water. So there's an H from here. And so if I just take out water. There's no more OH on this side, so I go over here. And then I have this over here. I have another repeat unit, right? We're taking another water out. And then you would repeat the same exact thing. So this is 1 unit. All you're doing is you're taking out water.
And she called that a, sorry. The bond.
Oh, it's a peptide bond.
Peptide.
Yeah. So this is the same as the proteins, right? When you're making proteins, you're just removing water from between. So all you're doing is removing water as you're combining.
And that's gonna be the same for any kind of nylon.
Yep, any kind of nylon. It's
Okay.
all that varies is just this number here. And so if you want to do it shorthand, write it out first. Because then when you do it shorthand, you know you're right.
Yeah.
So you just combine them. It's actually. Because there's no more OHs, because they all got taken out. Water covered. If you were going to make a polyester, it'd be the same exact thing. And so instead of it being this, it could be this. So all you would do instead of the nitrogens here, like this nitrogen section, it would just be CO, carbon, carbon, carbon. Right, instead of this nitrogen part. So, once you know how to make nylon, it's easy to make polyester. Any questions about this one? Did that help breaking it down?
Yeah.
Good. Again, I remember the first time she drew it up on the board and it was just too fast for me to comprehend, and I was like, where are all this coming from? So, breaking it down helps. Thank you guys for coming. Sorry, I literally looked at the clock, it was like 10 minutes. I thought we were on time. I felt good. No wonder she gets mad about that clock. It was completely off and it was just, yeah.
Okay, step up with the fashion.
Yeah. Every class time, she's like, what so all day? I'm like, did you expect it to be correct? Like,
Did it change overnight?
like, she didn't change it. I'm not gonna change it. I remember the one time somebody left a beer can on top of the clock and it took her all period to notice. So it was after like a week, it was after a weekend. And I saw it and I wasn't gonna say anything.
But she had a glass, what she thought that?